Tech Talk series of ICT Academy of Kerala. Today we have here an entrepreneur who has built unique products in our state. I welcome Mr. JK. JK, could you tell me about your product and yourself first?
Well, Asimo Robotics is specifically targeting the latest trends in robotics. That is again into a very specific area of service robotics, both in professional as well as personal services. So that's what is happening around the world. If you look at, you can see that the robots are becoming the part of our life. Unlike from the olden days where it was a part of the factory automation, now in various ways it is getting into our life. So Asimo has certain specific focus within services targeting the blue collar job sectors, and apart from that we are also into medical robotics, surgical robotics. So as far as the products are concerned, we are into customized service robots and various verticals like retail, education. Education, what I mean to say, education is not the education through robotics, particularly training, corporate training, and then healthcare. That is one of the areas we are looking at, very much interested in. And then of course when I say services, we are looking at certain verticals like healthcare, retail, education. So education means training, corporate training, and then banking. Banking, actually, there are a lot of verticals within which there is a commonality like hospitality. That is something which we are addressing. So that's what we started with, and that's kind of various products we work with.
So I'll go to the beginning here. So what made you start in robotics in the first place?
Actually, truly speaking, it was quite accidental. Like when I started robotics many years back during 1992, I would say, I was not knowing it is robotics. So I was very much interested in making things which is electromechanical and which is useful for day-to-day requirements. So during 1999-2000 period, I got to know that this is robotics through internet. Internet became popular, and then that's how I understood that it is robotics. So then I was searching for jobs in this area, sending out mails to various companies, and finally I understood that I have to start something to get into it.
Okay. So what were your first challenges in making your first product?
Well, actually, the challenges were, there were a variety of range of challenges because everything was a beginning at that time. So I was actually working as a project lead in a company called Galaxy, and then I got resigned during 2006, 2005 December to be precise, and then as I was saying, I was sending a lot of emails, and then a couple of companies responded outside India. At that time, there weren't much companies in robotics from India. So this company was from US, and they were into all sort of government services like for NASA, DARPA, all these government organizations in US and Europe. So they told me that they are interested in marketing one of their software products in India, which is developed under the contract of NASA. So whereas I was interested in technical stuff. And then I immediately replied that I'm not very much interested and I cannot do this marketing job. I have no experience in this. But immediately I realized that this is the only opportunity to get into robotics. So I said yes, and then I quit the job, and then I started my own company. So they wanted to have an entity here to do this marketing. That's how I actually had the same name that these people. And then I started sitting out. I was doing this sales mainly for the first year. And I struggled a lot, and by the end of 2006 I got 10 licenses sold, and that's the beginning. So one of the major challenges, as you were asking, generating fund and opportunity, and it was everything. At that time it was a combination of various challenges. So I could raise a good amount of money to start with, and then I started making this robot manipulators. Actually, that is one of the conditions I put forward to these people, that if I generate money, I should be able to do something technical, because my interest was that. So then I started this working with these manipulators, which was actually equivalent to human arm geometry, which was capable of doing almost everything that human could do with his arm. So I could send 4 or 5 units at that time to US, and then they sold it to various customers as pilot units. So that worked very much, and that's how the business started. And then it is, by 2010, we were able to ship around 4 to 5 manipulators, which means Robota, per week to US. And many people like the government organization like the US Army, US Coast Guard, then Stanford University, London Imperial College, Lockheed Martin, Canadian Space Agency. All these people are our customers.
Okay.
It was basically white label, so we were not mixed.
Okay. So, who was your first client and what did they find unique in your product?
After that, as a part of the story, I would say that we were separated from this company during 2012 to start Asimo Robotics. So, when I started Asimo Robotics, I was specifically looking at this service robotics sector. So, we made a robot for cooking and serving. So, which was able to cook a couple of dishes and then serve to the owner wherever he is sitting autonomously. But that was a kind of risky move. Why? Because nobody was interested in buying it as a standalone product. So actually, we were searching for customers, and that was that I couldn't do it at that time. So we started getting back to the robot arm business, targeting this Indian market, domestic market. So then we redesigned, enhanced the design, and then we sold it to various people like companies, major IT company like TCS, CTS, Accenture, HCL, Samsung. So they basically do this touch panel test automation, testing the touch panel devices exhaustively. So they replace the human component with the robot arm. So those people were the first customers, and fortunately by 2016 this video of the other robot was floated, and HPC happened to see this video and they approached us. They were also looking for making something in the banking hospitality field, robotizing it. So they came and then they decided together, and that's how ERA happened. Actually, ERA is the name by HPC. For us, our service robot series is known as Cyborg.
So I'm sure you work a lot. Just tell me about your past work activities. What do you do to remove this stress from your work life?
Fine. We even now in Asimo Robotics carry a theme like we make robots, so we are not robots. Of course, if you ask, you can see that it's not just limited to the robotics or any other IT sector. If you look at, we leave the left-hand side of the brain, so which is the logical part. So the other part is not getting addressed. So that's how we relieve the stress, so by using the right-hand side. Where I'm interested in many things, like I'm interested in music, and I do drawing, and then I act a bit like in short films, things like that, but not very much. And then I also do some individual research in terms of philosophical things. It's a blend of all.
And we know that in India there's a huge number of students graduating per year, especially in engineering. So what advice do you have to these fresh graduates?
Well, one of the key aspects which I could infer through these years is that India, being a country who has good potential in innovation and good background specifically in mathematics. If you look at India's 3,000 years of history, if you look at it, we were really good in mathematics. But somehow, because of the cultural difference which is brought in during the British colonization, and then because of that, somehow we lost that kind of ability to continuously innovating and getting into the latest technologies. we somehow become customers of all this. So now that if you look at, there are a lot of IT companies, you can see that in the BPO jobs, things like that. So my advice or suggestion, humble suggestion to the youngsters who are interested in getting into this field is that they should change the mindset. That's what we are lacking here. I can put it across through in a very brief way through two-line thing. So, if you want to innovate, if you want to come up with something which is unique, solutionize some problem, you should, in the first place, you should believe, hypothetically believe that there exists a solution, which means that he has the confidence to reach the goal. So that gives the confidence to reach the goal. So you have to believe somehow there is a solution. So if you think that right from the toothbrush to rocket has been already invented, nothing I have left out to be invented. Because of that, he sees a lot of problem, but he thinks that he goes to the implementation part. How does it is going to be implemented? What kind of thing? The making process I do this. That is nothing. Initially, you need to have that urge and belief in reaching the final goal. So you should believe that. Second thing is like, once if you develop something, you have a feeling that this is the ultimate, the best possible solution in the world. So then you should logically believe that there are multiple solutions for the same problem. So then only you start refining it. So these two things I have to tell from my experience I understood. So if you have these two things, very well you can reach the goal and you can keep on refining it and then maybe it will become the best solution one day.
That's great advice. So in Asimo Robotics, do you hire fresh graduates?
Yeah, we do have fresh graduates. Why? Because both fresh as well as experienced. So what the domain itself, robotics itself is more or less fresh. Okay. So if I start looking at the people who have experience in this area, there are people who are actually even Indians are working outside in major universities. So I got a lot of connects around the world with wanted universities, so I know what is exactly happening there. So a lot of people are there working outside. You call it right? But when we look for people from our geography, we have to opt for freshers as well. So we basically look at the learning curve, nothing else. They are able to adapt to the new technology.
Okay. So is that the most important thing for a fresh graduate to work in your company?
The most important thing. Yes, of course, that's what I was saying. See, again, I should be giving you an analogy or maybe an example from the philosophical aspect of it. So, see, every theory is refinement of various observations put together and then refined. That's how the theory is. There is no theory. Everything is observation of nature, getting things from observing. Again, a very simplest thing of maybe a wheel, right from a wheel to the complex mathematical equation which decides the trajectory of a rocket is also from the nature only. So one should be able to have good observation, and then the rest of the part is like if he is able to understand, then he learns the theoretical aspects. So you should be able to get connected to these observations, or should be able to map it to this so that he can apply it to the real problem. So if he is actually missing the first half of the circle, then he will be possibly missing the second half of the circle also. So you cannot apply it here. So that observation and understanding and ability to connect to the actual problem, that makes him a complete engineer. The engineer is not one who has gone through various courses like as BTech and MS and then PhD, and we don't believe in that. So this aspect should be there. So we will have multiple levels of interview to understand how the person is able to understand things, what is his approach.
So could you explain the technology behind this product, SciRobot?
Sure. So as robotics by itself is a combination of various technologies, right from mechanics, electronics, software, and then bit of aesthetics, same way. This robot is also is a blend of various things. But specifically asking the core technologies behind this, the mechanics is, I would say, it's a hyperdextrous robot, which means that it has many joints, many motors actuators working in tandem, and then this is a very specific strategy that we have followed. There are two different type of strategies in designing humanoid robots. One is from the top to bottom, and the other one is from the bottom to top. Bottom to top means you will be focusing on the bipedal locomotion, just like human beings are having. And then you once if you get a stable bipedal locomotion, you should be having the torso, and that's how it is. So that is mainly, if you look at it, you can see that there are very limited bipedal robots of this size, because even if it falls down, it's a major damage, and the balancing is complex. So there are many reasons for that. So whereas if you look at the practicality of using this robot in various sectors, you can see that the top down approach is much better, which means we start with the torso. So obviously what we have made, the whole world is made using these two arms. So just like that, we have very capable arms which has different configurations. We have 7 DOF, which means 7 joints, just like human arms are, and then bi-arms, two arms, bifurcated arms, and then we have 4 DOF, that means 8 DOF. So each arm is 4 joints of their length, based on the various application sectors. In the banking hospitality, we have 4 joints for the arms, and then there is a band mechanism for the head, and then in some other cases, you need to do a little more, like retail and all, handling things, handling liquid, and so where you have to maintain the pores, otherwise it will spill out. You need to have minimum of 6 joints. So, likewise, it varies. So that is the mechanics aspect of it. And then of course a lot of sensors, and it is actually on a mobile base which can float around. And then if you have a very flat surface, it has got a 2D differential drive system, just like 2 wheels, and there is a castle wheel as the third position. So that's a very simplest configuration for the mobility. And then if you have carpets or any bumps, things like that, you need to have the drive system with the shock absorbers, things like that. 4-wheel. We have 3-wheel drive, 2-wheel drive, and then 3-wheel drive, independent steering, 4-wheel drive, independent steering. Up to 6 wheels we have. Sometimes we need to have a lot of payloads, and then we need to distribute this weight among all these 6 wheels. So that is about the mechanism, the mobile base and the arms. And in certain cases, you need to handle objects wherein you need to have grippers, finger grippers. In the banking hospitality, we don't have that. We just have a passive hand. Then it does not have to do anything with that hand. And then if you have hand, when you have finger grippers, you need to handle different sort of geometries. Sometimes you need to handle a bottle, sometimes you need to handle a pen, or sometimes something else of different shape. So it has to be shape adaptive. So that is also there. So it's a combination. Depending upon where exactly we are applying this, we will combine, we will configure it. That's how we do that. That's the mechanics. And as I was mentioning the sensors, there are different sensors. Camera is there, image sensors, and then this laser sensors, they are for navigation. So that's how we navigate inside a room where it is deployed. And then I'll come to that in detail. And then we have all joints and encoders. Almost all the robots that we make are trainable, which means that you can put in the assistive mode, and then you can grab the end effector of the arms or whatever joints with your arm, and then you can make it move in space. Then the robot will record the trajectory by itself. At that time it will be in 0-top mode. That you can replay. So quickly, if you want to make a robot do some gestures or do some tasks, that's how we do that. So encoders are there, and then proximity sensors, IR sensors, and then this range finders. We have this sonar range finders, and then tactile sensors on the fingers if we are using adaptive gripping, and then microphone arrays there. Sometimes you have to localize from directly the direction of the speech, incoming speech. So you have an array of microphones. So that's how sensors. And then of course software is there to get it all work together. So it should have an intelligence in the sense. Again, if you look at the software architecture, you can see that it is multi-layered. So first you have to handle all these actuators, sensors, and then on the top of that you have to get it working in a combined fashion. So we typically in our terms we call it as inverse kinematics and dynamics. So on the top of that you had a behavioral level where it is very much specific to the application. So you get a lot of information from the environment, and then you might be requiring a specific task to be done based on the by interacting with the environment. Say for example, the robot has to, when you say the robot, let's say hi here, it has to sense your voice, it has to look at you, it has to identify your face, and then say hi, this gesture. So it's getting the information through the camera, and then first the microphone will localize where exactly it is coming. I'm just putting an example so that it will be easy for you to understand. So then it will be, the camera will be pointing to the person, and then he will be in the frame. So then thereafterwards it will keep on tracking your skeleton. So wherever you move, it won't leave you, it will be keeping you inside the frame. So then when you say hi, so it identifies the gesture, and then it goes to the behavioral layer where it identifies that this person is actually saying hi to me, and then it has to send a command to the lower level where all these models should work in tandem, and then they say hi, and then then it has to synthesize the text saying hi back to you through the speaker. So that is a very complex thing, but this is how it is. All these commands, the data flow is happening. So, but in banking hospitality, you don't need much. It's a very simple case I was explaining. There are a lot of complex cases in healthcare at all. That's how we're putting all together. So we have algorithms addressing all these things. So it's a lot of things put together.
So, as an entrepreneur who has been in this domain for quite some time, what are your views on the startup ecosystem in the state?
See, the startup, actually the concept of having startups, the so-called startup which has that hockey stick growth curve, started during I think 2012 in Kerala specifically, as a part of the startup village. At that time it was startup village actually. So that is also evolving, I would say, because when you think of, I would go with the previous example I was putting, that when you think of coming up with something new, innovative as a product, the concept is there, the prototype is there, and then the productization is there. So what basically the ecosystem gives you is not from the ideation level, it will be helping you from the productization and then the marketing, things like that in various ways. So when you try to prototype, right, from prototype to productization and then marketing, things like that, you need to have very basic facilities depending on your product. If you have a software idea or a product in hand, then or in mind, you need to have that sort of setup, like a good computer and then a space to sit, and then maybe you have to have a lot of brainstorms, things like that, and a very basic structure which is typically available in an IT environment. That is good enough. And then if it is a hardware product, then you need to have some way of making it, and then when you try to do that, you should have a lot of facilities, which is again, in our case, it is very complex. Like, we need to take care of the electronics, we need to take care of the writing software, we need to take care of whatever software, we need to take care of making the hardware, the internal structures, the cover. So that again, the productization I'm talking about. You can just make a product, when it becomes a product, a lot of refinement. Look at the product designing aspect. You need to make a cover. So you need to have, let's say, like a lot of, if it is of metal, you need to have a lot of metal shaping tools. Now that, to start with prototyping, you have 3D printers. Even though the current scheme is deposition, which takes a long time, if you want to print this robot, it would take more than 1,000 hours in 3D printer, and the volume is small. But that's how you can start with. If the small product is fine, you can start with 3D printers. So that should be there. So you have a design in the 3D modeling space, and then you give it to the printer, and the printer prints the part, and then you have to put together and paint it, and there are a lot of machining process involved. For example, if you look at our robot arm, it has a bearing which is very specific, made out of Berlin, and then a lot of turning, machining jobs. So you need a lot of hardware for this. As a product getting more complex, you need a variety of hardware. So that's what typically. Now I think there are two centers, or the prototyping centers in Kerala, which is typically called as this MIT Fab Lab. One is in Kochi, one is in Trivandrum. So that gives you the prototyping facilities. And then if you go to productization, obviously number of units, that is not just limited to that. That's not actually the ecosystem is aiming at. You need to prototype it, and then you may have to go outside India to make it in volume. And then there are a lot of mentoring activities happening, like how to make a pitch deck, and how to pitch it to the investors, and then how to identify the first customer, and then they will attracting investors. So actually the ecosystem should be a very much like a happening place. You should have and then of course this evolves to community. There are the community meetings and things like that. People have different sort of problems, so they can exchange ideas and problems with each other. So you may be probably getting a solution from the next door company itself. So that is how the ecosystem. So that is actually getting involved. I think we are also enjoying a lot of facilities. We are working out of Kerala Startup Mission, and then I think so that's why we have regular meetings, and then we work together, and then that's how it is evolving. It's evolving, and it's a very good fashion it is as of now.
Okay, great. So the final question I want to ask you: what is the future of Asimo Robotics?
See, Asimo, if I'm not exaggerating my words, I would say we are actually addressing targeting the global market, not just limited to the Indian customers. Why? Because robotics is like that. If you look at the technology space, you can see that we were always following the trends which was happening in the Western countries. So if you take the example of computers, mobile phones, whatever it is, we are just trying to follow the things, the trends, technological trends happening outside India. And once it is adopted, I think that then we have proved that we can become masters in it. So robotics is not different. So Asimo is always targeting the market is also like that, the market outside India. So we have plans to become one of the best companies in robotics. So who are making solutions for various problems, wherein we are actually missing a lot of resources in the coming days. If you look at this, I can tell you with a lot of confidence that there are a lot of areas where we are going to have a shortage of resources. Typically blue collar jobs. One is the case, I can tell you, this security jobs. You can see only all elderly people who are actually not fit for that job. So you won't be getting youth for that. So there are many cases where you won't be getting youth to be taking care of what is required in within a sort of market. So in the coming days you are going to see that. So all these areas robotics can support, and then of course this defense and space, all these sectors, there are a lot of requirements. So Asimo is actually equipping ourselves to target all these markets, starting with service robotics, specifically to healthcare and then hospitality aspect. So our product is not just what is it like a firm product. It is highly flexible, it's highly customizable. So today this robot can do something in terms of hospitality. Tomorrow it is not difficult to make it useful for a completely different environment. So that's what we are targeting. That's what our future is like. we will be coming up with variants of this in the coming days.
Okay, JK, we wish you great success from our side. Thank you so much for your time.
Thank you very much. Thank you.